Okay, hello ladies and gentlemen. This is your um, lesson over normal distribution. Now, a couple things I want you to realize is that we've already talked about normal distribution, and I'm just going to reiterate some of the things that you should know. Normal distribution is a good description for some distributions of real data. It's also helpful when you it has good approximations to the results of many kinds of chance outcomes, and also many statistical inference procedures are based on normal distribution. Well, you've heard me talk about normal, and so let's go ahead and explore what normal is. All right, normal distribution, if I were to describe it, it's usually it is symmetrical. It is usually single-peaked and bell-shaped. Now, whenever I draw that, what that means is single peak means it's going to look something like this. All right. Now, notice I'm going to go ahead and put a bar underneath. This is my number line where we show the standard deviations. All right. Notice it doesn't touch right here. All right. It doesn't touch. It'll get close, but it doesn't touch. It'll tail off like it's doing. Okay, it's bell-shaped, and it has this single peak there. All right. Now, also, the mean and the median lie together at the peak. So, the mean is right here. Well, that means also x bar is also there because it's symmetrical. All right. Now, let's go ahead and go to the next page. How to draw and describe a normal curve. All right. The points at which a change of curvature occurs is a standard deviation, and we're going to describe using the mean and standard deviation because it is symmetrical data, and then the standard deviation determines the shape. So remember when we talked about variance, if the variance is large, then the standard deviation is going to be large. If the variance is small, then the standard deviation is going to be small as well. So let's take a look at a picture here. Not that just yet. All right, so if I take a normal curve, all right, let's just see if I can draw one right here. Not very good. Usually I have one already done. All right, let's just say this is my normal curve. It's actually a little, that's 2 and 1. Let me see if I can draw it one more time, okay? Sorry about that. All right. All right, let's just go ahead and use this, all right, for my normal curve. Now, notice, right here in the middle, oops, a little off, is going to be my x bar, all right? That's going to be our mean. Now, we're going to change that here in a second, but that's my standard deviation of 0. That's my standard deviation of 0. Where it starts to curve here, where it starts to break right there, we're going to drop down, and we're going to make that a standard deviation of -1. And where it starts to curve right here, we're going to make that a standard deviation of 2. And when it starts to flatten out right here, we're going to make that a standard deviation of -3. All right, now, because it's symmetrical, where it starts to slope down right here, we're going to go ahead and call that a standard deviation of 1. Where it starts to curve again, we're going to call that a standard deviation of 2. And again, when it starts to flatten out here, we're going to call that the standard deviation of 3. All right, those are points at which where the graph starts to curve. That's where your standard deviations are. Okay, and we're going to learn a little bit more about this in a second. All right, now, when you draw your normal curve, there is something called the empirical rule. All right. Now, recall that when we try to find the 5th percentile, that basically tells you what percentage you are at or greater than. All right. This does similar to the same thing. It just kind of tells you what percentage of the observations fall within these numbers. So let's take a look. Between the first standard deviations, you need to know that 68% of the observations fall within that area. All right? And if you look at 95, All right, those are the second standard deviations from -2 to +2. This distance, 95% of my data, oops, let me go ahead and change that. 95% of my data, of my observations fall within this, okay? So 95% of my data fall within those two standard deviations. And then finally, 99.7% of all the observations fall within 3 standard deviations. And we're going to use this feature that incorporates area under the curve to answer a couple of questions here shortly. All right, now let's go to this next page. Okay, now if you look at this, I'm going to take this feature right here, and I'm going to take my empirical rule, and I know that this right here is 68%. Now, if you recall, this normal graph is symmetrical. And because it's symmetrical, that means this portion and this portion are identical. Okay? Now, if you do that, since they are identical, these two areas should be the same. So half of 68 is going to be 34%. All right? So 34%. So those two are 34%. If you continue, all right, if this is 95%, well, I've already used 68%. So if I take 95 and I subtract 68, all right, what should I get? Well, if you notice, you'll get around 27, okay? You'll get about 27. That means this distance here and this area here have to add up to 27. Well, I've already got 68 here in the middle. So now 27 divided by 2 gives me 13.5. So that means this right here is 13.5 and this right here is 13.5. Now if you add those up, 68% plus 13.5 and 13.5, well, obviously what you're doing is really adding 68 plus 27, and that should give you 95. And so you just kind of double checking your work. Now, if you've noticed, we've already used 95%. All right? What I have left is from here to here, and that is my 99.7%. Now recall that the area under the curve is 1. The area under a density curve is 1. That's what a normal distribution is. It's a density curve. So if I have 99.7, that means this area and this area, we're talking about this area underneath the curve right here, has to add up. If I have 99.7, and I subtract 95, that leaves me with 4.7. Okay? Now that's going to give me a small number. So half of 4.7 is going to be 2.35. So that means this right here is 2.35. And that means this little area right here is also 2.35. Now, notice how I've broken down this entire graph. The last thing I want to cover is I want you to come tomorrow with an idea of what these two little circled areas are. Okay? Quickly moving because we're already up to 9 minutes. All right, couple things for tomorrow you need to know. The standard normal distribution. Now, we've already used how to find a standard score. Okay? Now, I want you to notice, in a normal distribution, we have a mean of 0 and a standard deviation of 1. Okay, now, notice some of these things. This right here are my observations. All right? These are my observations. This is called mu. This is called mu. This is nothing more than my mean. And sigma is nothing more than my standard deviation. All right. Now, normally what we've talked about in the past is whenever I use this, what y'all have found out is that that's for a population. And quite often a normal distribution describes the population or the distribution of a population. So just to kind of show you a few things, this is what we call Table A, and y'all have been working on this with your Khan Academy. This is nothing more than our z-scores. These are the positive ones. So let me go ahead and move this out of the way. All right. And let me just bring this up a little bit. Now, if you notice, these are, if I had a z-score of 1.13, if that was my standard score, that was my z-score, what I do is I look at these two numbers first, and I find 1.1. That's this row right here. Okay? Then this 0.3 is up here. Oops, sorry. 0.3 is right there. So I have to see where those two meet. And if I go here, if I go 1.1, 1.3, this little number here, I don't know if you can see it, but it's 0.8708. That is the percentile that that z-score relates to. All right? Same thing over here. These are all your negative z-scores. So you could find the percentage that relates to. All right, I'm going to move on to the next page because I don't want to run out of time. Whenever you find a z-score, you have to draw the graph. You're going to draw a line straight up. Always draw your normal graph. And then you always shade the area to the left unless it's asking for, if it gives you a scenario that is actually asking for the area to the right. Okay? Again, if I said, okay, 1.33, if I wanted a negative 1.33, that would be, here's negative 1.3, here's 0.3. Together, they make negative 1.33. So there would be my area under the curve of 0.0918. All right? Kind of look at this. This is a z-score of negative 1.25. So if you notice, negative 1.25 is right here. So that's a area of 0.1056. All right. And then finally, this is just another picture. What we're going to cover this tomorrow is how you find an area between two standard deviations. All right, and we'll cover that tomorrow. All right, that is my lesson for the day. Have a good evening.